All right, this is a really good problem. Let's do the force diagram over here. So we're going to do the person as the dot. So we know we have force gravity, and I'll draw it the way the picture has it. This would be the force of the parachute, which I'll use as a P, and then this below the angle would be the force of the boat. And we have some angles here, I believe. This one's 30, and this one's 15, I believe, if I drew that correct, and I think I did. So really what we have to do is we need to see that there is the force of the parachute in the y direction, and there is the force of the boat in the y direction, and then there's also the force of the boat in the x direction, and of course we have force of the parachute in the x direction. The force gravity is already in the y direction, so let's start summing up our forces. Some of the forces, let's do the easy one first, the x direction. We know it equals 0 because it's not, oh, can you tell him it's school? We know the acceleration, it's a constant speed, and that's kind of the section we're on, so we know the sum of the forces equals 0. So the one force we have is negative force of the boat in the x direction plus the force of the parachute in the x direction equals 0, which would turn into force the parachute in the x direction equals the force of the boat in the x direction. All right, one thing I kind of missed here is the tension in the rope is 2300, and the rope, I believe they're calling the boat, so that's going to be a 20, am I in the right color here? 2300 newtons here. So really what I have to do is I'm going to have to find my x and my y, and then I can put my 1x over to the other side because these should be equal. The two blues should be equal because there's only two, and then I can start to fill in the blanks here. Maybe I wasn't very clear here. The question mark is that right there. So that's the question mark. All right, so let's start kicking out these numbers. Let's go FBX first. And FBX is the adjacent, and I have hypotenuse, so I'm going to go cosine of 15 degrees equals adjacent, which is FBX, over hypotenuse, which is 2300. Multiply 2300 by both sides, cosine of 15, and that should give me FBX, and that's going to give me, and my calculator gives me 2221, we'll round up to 22 newtons. So that's up here, 22 newtons. And now I can get FBY just by sheer 2300 squared minus 2222 squared, square root answer. Oops. And I get 594 newtons. Now, because this blue one is 222.22, this blue one automatically has to be 22.22 newtons. And now I can start getting this other y and the x, and I can start doing a lot of stuff here. I really just need that y. So let's find out this red y right here. And let's go. So I know I have adjacent and I need opposite. So tan of 30 degrees equals opposite, which is FPY over adjacent, which is 22, 22, 22. And that turns into 22, 22 newtons multiplied by the tan of 30. And that equals 1282. Let's go 1283. Now, here comes the fun. You ready for the fun? I know I am. I have all my y's. So let's go. Let's do this. So sum of the forces in the y direction equals 0. I have force parachute y minus force boat y minus force gravity equals 0. And I can start filling in numbers here. Force parachute y is 1283 newtons, negative 594 newtons, minus Fg. I'm going to throw that to the other side. And this turns into Fg. So 1283 minus 594. 1283 minus 594. I get 689 newtons. Seems about reasonable for the weight of a person. Woo woo. Woo woo.